In here, I'm going to show you a couple of steps now for you to get through this particular question that says that we have the number of copper 63 atoms in a cubic crystal of copper that measures exactly 25 nanometers on edge. Now, the density of copper is around 8.92 grams per centimeter cube, and the percent isotopic abundance of copper 63 is given to be what? 69.17%. If you ask to determine the number of atoms that are present in a particular object given the shape of that object, and it says that this object is a pure substance, how are you going to go about this? Now, there are 5 steps that are required for you to accomplish this particular question or solve the question. And the first step here is to convert to centimeters. Second step is to do what? To go to your volume from that length, and from there the next step is to determine the mass of the copper cube, and this is followed by the fourth step, which is determining the mole of copper in the cube, and the final step is what? Find the number of copper 63 atoms present in that cube. Now, let's look at the first step here, which is to go 2 centimeters. We know that we're given our value in terms of the edge to be 25 nanometers, which is equivalent to 10 to the power of -9 meters in terms of going from standard form to exponent form. And this here, to convert 2 centimeters, we multiply by 10 to the power of 2 centimeters over 1 meter, and that gives us this particular value here to be 25 times 10 to the power of -7 centimeters. Now, once we have this answer, this here is going to be needed for we to get to step 2, which is to determine the volume of this entire object. And this here, we notice based on the question that it is a cubic crystal. That means that we have a cube as the 3D shape, and the formula is in length cube. And so length times length times length, that means that we have 25 nanometers for the length, 25 nanometers for the width, and 25 nanometers for the height. Once we multiply those numbers together in centimeters, and this here is in centimeter cube, so 3 of these numbers multiplied together, that will give you your answer to be 1.56 times 10 to the power of -17 centimeter cube. Now we have our value for the volume. The next step is to determine the mass of the cube, which is made out of copper, and this here requires what? The following, where we know that the density will grant us access to the mass, where we know that the density is equal to the mass divided by the volume of that object, and that means to find the mass we need to cross multiply. That means our density of the cube is multiplied by the volume of the cube, which are in this case is made out of copper. And so once we do that, we know our density is given for copper to be equal to 8.92 grams per centimeter cube. And you see, that is why we changed this particular value here from nanometers to centimeters, because we are dealing with centimeters here. And so back to this problem here, we are going to do what? Multiply our density by the determined volume, and this here will enable us to determine the mass to be equal to 1.394 times 10 to the power of -16 grams. Now we have this for our third step. We're going to move on to the fourth step, which is to determine the moles of copper in the cube. And to accomplish this, what we have to do is the following, where we have to use the mass of the copper cube that we determined, and what? We need to use the molecular weight of copper in order for we to what? Determine what the moles is. And to do this, all we have to do is divide our mass by the molar mass, and that will give us the number of moles of copper. And once we have this established and put our values in the equation, we are going to determine our final answer to be equal to 2.19 times 10 to the power of -8 in moles of copper in the cube. Now, why do we need to find the number of moles? The reason why is because out of that many moles, we have a fraction of that is copper. What? How much? Copper 63 as the isotope. And so how do we accomplish this? That leads us to the final step, step 5, where we need to find the number of copper 63 atoms that are present in that moles. And there are 2 steps that are required here. And then in here we have 3 things that we need in order for we to accomplish this. And the first thing is we need to use the number of moles of copper, then the percent abundance of copper 63, and finally is the Avogadro's constant, which is this particular value atoms per mole. And so once we have those 3, we're going to organize them in terms of applying an operation in order for we to solve that problem, which means we're going to multiply all those numbers together. And once we are able to do this, it's going to look like this to determine the number of copper 63 atoms. And this here is what we need to do in order for we to determine what the final value of copper 63 atoms, and the value here is 913,598 atoms approximately. And so this here is our final answer, and this answer is how many atoms that is copper 63 present in that particular copper crystal that is a cubic shaped object that has a nanometer measurement on the edge to be 25. So I hope you found this really informative in terms of following all these steps here in our way to determine the number of atoms, specifically copper atoms, specifically again the isotope of copper atoms present in a pure substance in a cubic shaped object. All the same, stay smart as always. Let me know your thoughts about this in the comment section down below. By that way, we can talk to you soon. Stay smart as always and believe in yourselves.